We're starting a brand new topic today, so I would like you to use your Chromebook or your cell phone and research what absolute value is. Make sure it's math related, or you could search for absolute value equations. You could look on images, you could look on web. Write down something that you can find about absolute value. Open your books to page 49. We're starting a brand new activity. It's activity 4, and it's all about absolute value equations and absolute value inequalities. So we're starting in lesson 4.1. It's titled Absolute Value Equations. So today we are going to look at understanding what is meant by a solution of an absolute value equation. We will probably get into solving these later on. So we have Miss Patel, who is preparing the school marching band for homecoming. Okay, she has a row of band members stand in positions along a number line on the floor of the band room. The students' positions match the points on the number line as shown below. So what we are going to do is we're going to use this number line in order to write each student's distance away from 0 next to their name. So for example, it says Tania is 2 units away from 0. So you see that she's right here, 1, 2, 2 units away from 0. So I would write a 2 next to that name. Israel's distance from 0 is also 2 units away, even though he is standing at -2. If we count 1, 2, he's also 2 units away from 0. So pause the video, take the time, count how far Derek, Kia, Mara, and so on are away from 0 and write it next to their names. So Derek is 7, Kia is 5, Mara is 3, 6, 0, because Laura is standing on 0, Antoine is 3, Nick is 5. So you might have found in your research that the absolute value of a number is the distance from 0 to a number on the number line. I'm reading it straight from your book. Okay. If we are using absolute value notation, Mara's distance looks like this, the absolute value of -3. Antoine's distance looks like this, the absolute value of 3. Okay, those bars represent or stand for the absolute value of. So Mara and Antoine are both 3 units away from 0. So if you're looking, -3 ends up being 3, and 3 also ends up being 3. So the absolute value of -3 equals 3. The absolute value of 3 equals 3. Why? Because the absolute value of a number is the distance from 0 to that number on a number line. So we're going to write out each person's distance from 0 using absolute value notation. So our first student was Derek. And where is Derek standing? Derek is standing on -7. So we're going to write the absolute value of 7. Kia is standing on -5. Mara is standing at -3. And now I want you to keep going with the other students. So you might need to pause the video and write down their absolute value of where they're standing. Tania is 2. Sam is 6. Laura is the absolute value of 0. The absolute value of -2. The absolute value of 3. The absolute value of 5. So these bars mean the absolute value of. The absolute value of. Absolute value equations can represent distances on a number line. Number 3, the locations of the two students who are 5 units away from 0 are solutions to this absolute value equation. The absolute value of x equals 5. This equation represents the two students that are 5 units away from 0. So I want you to write down which two students represent the answers to this equation. Which two students are 5 units away from 0 on your number line? Kia is 5 units away, and so is Nick. Kia is standing at -5, which is 5 units away from 0. Nick is standing at a +5, which is 5 units away from 0. So go ahead and turn your page to 50. Question 4 says, we can create a graph on a number line to represent the solutions of an absolute value equation. So we are going to graph the solutions, Kia and Nick, for this equation right here, which is the absolute value of x equals 5. We're going to graph that on this number line. And then we're going to explain why it makes sense that this equation has 2 different answers or 2 different solutions. So if I'm graphing, let's graph Kia first. So where was Kia standing on the number line? Kia was standing at -5. So we're going to put a point at -5. Nick was also standing 5 units away from 0. Nick is standing at 5, so we're going to put a closed circle at 5. Why are there 2 answers? Well, let's count. 1, 2, 3, 4, 5 units away from 0. 1, 2, 3, 4, 5 units away from 0. So there are 2 solutions because there are 2 points that are 5 units from 0. Absolute value is the distance from 0 to the number. So we're always going to have 2 answers, 2 solutions. So the answer to this equation is -5, because that's where we put one of our points, and the other one is a +5. They are both 5 units away from 0. Absolute value equations can also represent distances between 2 points on a number line. So I want you to answer question 5, and you might need to flip your page or your book back to that number line where our band students are standing. And you need to answer, in the student line, which 2 people are 4 units away from 1. So write down their names. And then mark their location on this number line. So the 2 students are Mara and Nick. Let's see, how did we get that? This is the number that we're starting. Okay, we're starting at 1, and we're going 4 units away. So we need to go 1, 2, 3, 4. And then we need to go 4 units away the other direction. 1, 2, 3, 4. And there's our second point, our second dot. Mara is standing at -3. Nick is standing at a +5. So our answers here would be -3 and 5. -3 and 5. Again, we have 2 answers because there are 2 numbers or 2 students that are 4 units away from 1. We had to move 4 to the right and 4 to the left. Okay? Now, the equation absolute value of x equals 4 represents the numbers located 4 units away from 0. So this equation right here represents the numbers that are 4 units away from 0. Notice 4 is outside of your absolute value bars. 4 is what we're equal to. This equation could be written as x minus 0, because 0 is our starting number or our starting point, equals 4, and 4 is the number of units away. How many spaces we're moving to the left and to the right. But remember, mathematicians are a little bit lazy. We don't write -0 or +0, we just drop it. So these 2 are equivalent to one another. They both say which x values, what numbers are 4 units away from 0. Okay. In question 5, we were looking for numbers that were located 4 units away from 1. So this equation looks a little bit different. This 4 is the number of units that we're moving away. Okay. This 1 is like our starting number, our starting location. Got it? The absolute value of x minus 1 equals 4. Okay. Any questions? All right. Number 6. What are 2 possible values for x minus 1 given that x minus 1 equals 4? So what could I put inside of these absolute value bars to equal 4? Think back to Mara in the example on the previous page. So if I want whatever is inside of here to equal 4. It has to be 4, and it also has to be a negative 4, because these numbers are each a distance of 4 units away from 0. And the absolute value of 4 equals 4, and the absolute value of negative 4 equals 4, because they're both 4 units away from 0. They're both 4 units away from 0. So here's what we're going to do for question 7. Stick with me. We're going to use the two values that we found above, so 4 and negative 4, and we're going to write two equations showing what x minus 1 could equal. X minus 1 could equal. So now we have two equations, and we are going to solve both of these equations separately. So draw my line down. I want to get x by itself. So what I need to do here is get rid of this minus 1. So the opposite is to add 1, and we get x equals 5. That's one of my answers. Over here, I solve the exact same way. I add 1, and we get x equals negative 3. X equals 5 and x equals negative 3. Wait a second. How do the solutions relate to your answer from question 5? And I can't extend my page here. So I'm going to go back up to question 5. Look, what were our two answers here? We had a point at negative 3, and we had a point at 5. So we just solved and found out which two numbers are 4 units away from 0. We got 5 on our number line and negative 3 on our number line, but when we solved using algebra, we also got 5 and negative 3. So because I can't extend my page, I cannot write my answer under question 8 or under question 9. But they are the same. Can't fix that. My computer's acting funky. So we got 5 and negative 3. Okay. Moving on to question 10. We're going to draw a number line. Okay, here's my number line. Draw a number line to show the answer to each question. Then write an absolute value equation to represent the points described. Okay, which 2 points are 2 units away from 0? 2 units away from 0. So I'm going to put a 0 right in the middle. And I'm going to go 1, 2. And I'm going to go 1, 2 in the other direction. So if I start at 0, 2 units to the right, I have a point at 2. Start at 0, 2 units to the left, I'm at negative 2. So there's my number line showing my two answers. All right, I'm going to start with my absolute value bars. And it's x minus, it's always x minus your point. What was your starting point? We started at 0, this number right here. So x minus 0 equals how many units away did we move? We moved 1, 2 units away, so my equation is equal to 2. Well, remember, mathematicians don't want to write minus 0, so your equation could also be written as the absolute value of x equals 2. Okay, so sometimes I tell my students a little hint. X minus your starting point put your absolute value bars, equals how many units away that you're moving. So what I would like you to do is I want you to pause the video and I want you to do your best, please, to answer questions B and D. Have some confidence, draw on a number line, you can do it. We are moving 5 units away from -2. So I'm going to put a -2 in the middle. So this is our starting point at -2, and we want to move 1, 2, 3, 4, 5 units away. So put my circle there. 1, 2, 3, 4, 5 units away in this direction. So my answers are +3 and -7. +3 and -7. Those are my answers. But now we are going to write the absolute value equation. So let's start with our bars. And it's always x minus our starting point, which our starting point here is -2. So x minus a -2 equals how many units away did we move? 5 units away. So equals 5. But we know that 2 negatives make a positive. So we want to turn this into x plus 2 equals 5. So that's my equation. My answers to that equation are -7 and +3. All right, next, let's draw a new number line. We're starting at 4, so I'm going to put that in the middle. That's my starting point. And I'm moving 1, 2, 3 units away. 1, 2, 3 units away the other direction. So this time, circle's at 7, circle's at 1. So 1 and 7 are my answers to numbers or points that are 3 units away from 4. And let's write this equation. So start with your absolute value bars. X minus my starting point, which is 4, equals how many units away did we move? 3. 3 units away. Question 11. This is saying which two x values are 10 units away from what number is inside of my absolute value bars with the x? There isn't a number there. So 10 units away from 0 on your number line. So think about it. If you start at 0 and you go 10 to the right, you're going to be at 10. And if you go 10 to the left, you're going to be at -10. So these are our two answers here. -10 and 10. Now, remember, absolute value means distance away from 0. So this equation is saying which x values are -3 units away. Well, some of you in your research said the absolute value cannot be negative, right? I can't run -3 miles. Even if I'm running backwards, I'm still running 3 miles. So this has no solution or no answer because we cannot move -3 units away. If I'm moving 3 to the right and 3 to the left, it's still a +3 units. So this has no solution because absolute value cannot equal a negative number. But notice over here, our answer can be negative. So we are going to stop here, and we are going to continue solving these questions with a note sheet tomorrow.